Hi everyone, thank you for joining us today. I am one of the product managers at Altech Corporation in Flemington, New Jersey, and my main focus is our safety products. Since 1984, Altech Corporation has been an established United States supplier of components and devices used in industrial control, instrumentation, medical, and automation applications. Altech offers a broad variety of product lines, including control panel components, circuit breakers, disconnects, contactors, enclosures, terminal blocks, and safety devices. We are known for supplying high-quality products at great prices. We offer products under our Altech brand name, and we represent several companies from around the world whose products we sell under their brand names. Our company's heritage and many of the products that we supply are from Germany. Most of the safety standards that we use today originated in Europe, particularly in Germany. So safety products are a natural addition to our line, since we deal with so many German high-tech manufacturers. I originally started working with safety products 30 years ago when no one knew what a safety relay was. In those days, it was common practice to run the machine power directly through the safety switches for smaller machines, or the safety switches could be used to control the coil voltage to a master control relay, also called an MCR. It worked, but there was no way to detect if the contacts to the master control relay or the safety devices were welded or broken, or if there was a short in the wiring. The only way you found out was when you opened a door or hit the e-stop button and the machine kept running. A truly safe safety system needs to be control reliable, or fail-safe for the lack of a better term. According to the standards, this means you need to create a circuit which does not rely on any single component to ensure the correct function of the safety system. Control reliability implies that the safety device or system is designed, constructed, and installed so that the failure of a single component within the device or system shall not necessarily stop the machine immediately, but shall prevent a successive machine cycle from taking place. You can fix some of this by adding redundancy to the safety circuit, which means adding redundant contacts to your safety devices as well. This addresses some of the issues, but it doesn't provide a complete solution. According to the standards, even when redundant components are used, the failure of one of the components will cause the machine to revert back to its original dangerous condition. In order to prevent this, both circuits and components should be monitored. If the failure of one of the components is detected, it's not necessary to stop the machine immediately, but it should prevent a successive machine cycle from taking place. The easiest way to monitor the circuits and components is to use a safety relay in place of the master control relay. The safety relay checks continuity for both safety circuits, and if both circuits are closed, provides one or more closed outputs. Some also check polarity to ensure there is no cross-wiring. Detection of cross-polarity or an open safety channel will cause the safety relay outputs to immediately open. An optional reset button can be used for restart, or the relay can be wired for auto restart, which provides closed outputs whenever both safety channels are closed. If the continuity of either safety channel is broken, by opening a door or pressing an e-stop as an example, the safety circuit outputs will immediately open. The continuity to both safety channels must be restored and the reset button pressed for manual reset versions for the output contacts to close. The safety relay monitors both channels for simultaneous operation as a way to check that the safety device is working properly. If both safety channels do not change state within half a second of each other, or if only one channel is detected, the safety relay will go into a fault mode, requiring recycling of the safety device or repowering the relay before it can be started. By adding a redundant circuit and monitoring with a safety relay, we now have a safe, control reliable circuit, which manufacturers have been using for years. But then someone found a problem. Let's go back and look at our redundant monitored safety circuit. Here, both doors are open, so the machine cannot be started. If both doors are closed and the reset button pressed, for manual reset versions, the machine will start. If a failure develops on one of the safety devices, or the wiring for that safety device, the machine will keep running with the doors closed. When the door is open and closed, the fault will be detected, and the safety relay will go into fault mode. Fault mode will prevent the machine from restarting, even after the door is closed. To start the machine, the fault must be corrected, and the safety device must be recycled, or the safety relay must be repowered. However, if that door is closed and another door is open and closed, the safety relay will interpret that as an indication that the fault has been corrected. This would reset the safety relay and allow the machine to be restarted, even though the original fault condition still exists. This could eventually lead to a double fault, which would allow the door or panel to be opened when the machine is running and in a dangerous condition. This problem is called fault masking.
In machine safety, fault masking is often an underestimated problem. Safety guards of machines are often protected by electromechanical safety switches. If there are several doors, they are usually connected in series and connected to a safety relay. Series connections of electromechanical contacts create a problem. Imagine a wiring error occurs in one switch. After activating the switch, the machine can't be started again. So far, so good. But if then another switch is activated, this fault is overwritten. Due to this fault masking, a second wiring error will also not be recognized, which leads ultimately to a dangerous situation for the machine operator. A problem that Bernstein eliminates with its Smart Safety Sensor, SRF. The SRF is the electronic solution with self-monitoring electronic outputs. The SRF sensors recognize at all times if there is a wiring error or not. If an error occurs, they switch off the system in a controlled manner. This is the main advantage of the electronic SRF safety sensor. Thanks to SRF, the system cannot be restarted if a fault occurs. That's why it's called smart. That's why it switches safely, even in a series connection. With the Smart Safety Sensor from Bernstein, the problem of fault masking is a thing of the past.
And since safety devices include emergency stop buttons, they added additional information.
Where to connect the emergency stop device. In accordance with the Machinery Directive, each machine has to be equipped with at least one emergency stop device. These emergency stop devices are typically equipped with electromechanical contacts. If these are now connected in series with other electromechanical safety switches, the possibility of fault masking arises once again. To solve this problem, Bernstein offers an electronic emergency stop device, specially adapted to the SRF safety sensors. This electronic emergency stop device fits perfectly into the SRF series. Simply integrate it via the M12 connector, and that's it. And despite a series connection, you no longer have to worry about fault masking. In addition, the electronics allow the transmission of extensive diagnostic data so that your machine can work very efficiently. This creates the basis for predictive maintenance. SRF and SEU. With Bernstein, your machines will be Industry 4.0 ready.
Bernstein's smart safety system addresses this situation by wiring the network in a different way. Instead of wiring all the switches in the series circuit, the Bernstein smart safety system uses a cascading system. When the first door is closed, it communicates to the next sensor downstream. That sensor checks to make sure it has received the signal from the first sensor and that it is closed, and then communicates to the next sensor downstream, and that continues down the line. This cascading chain can be extended by up to 32 sensors. Instead of 24 volts DC, the Bernstein Smart Safety System uses two OSSD outputs, which stands for Optical Signaling Switching Devices. These are pulse signals. Our Smart Safety System features a plug-and-play M12 connection system, which provides plug-in installation convenience, saving time, wiring errors, and labor. Individual sensors are connected to the series line using T-connectors. The series line uses a 4-conductor cable, offering an additional cost savings. Components can be added and removed simply by plugging and unplugging them in. The safety relay is the only thing that needs to be manually connected, and that only takes 4 wires: OSSD1, OSSD2, positive, and negative. All versions of the system include either PNP or daisy chain diagnostics, which are designed to provide status indication to the machine's control system and aid in troubleshooting. This is separate from the safety outputs. PNP diagnostics are the simplest type, providing a PNP output when the door is open. These outputs are designed to provide inputs to the machine's control system to help its operation in addition to the safety relay shutdown. Some systems are available with an integrated bus system, which we call daisy chain diagnostics, or DCD. The bus system carries 24 different types of information from each sensor. This can be run into a diagnostics module, where it can be read by a PLC via I/O link or by a PC with a USB cable. Sensor status can be read locally with an Android-based smartphone or tablet using NFC, near-field communication. Both the Android NFC app and the PC software are available for download at no charge. The most popular sensor used in this system is our SRF non-contact safety switch. These feature RFID communication. They have a safety rating of Category 4 PLE SIL 3, a protection rating of IP69. They offer low, high, or unique coding options with easy-to-keychain coding features. LED diagnostics, fault tolerance outputs, with options including local reset button, PNP, daisy chain, I/O link diagnostics, Android, near-field communication smartphone monitoring. These are designed to replace keyed safety door switches, which can have problems with alignment. We also offer an enclosed e-stop button with OSSD outputs. This has an M12 plug-in connection, a twist and turn reset button, built-in LED status indication, and optional DCD diagnostics. Diagnostics information is available from every e-stop device and will allow you to identify if the switch-off signal is caused by the emergency stop or by a sensor. Our system can also be used with standard dry contact safety devices. We offer a transition box which converts dry contact outputs to OSSD outputs. Standard components such as dry contact safety switches, limit switches, and hinge switches are available with M12 connectors to allow for plug-in installation. Whether you're interested in preventing fault masking or you would like to add a higher level of diagnostics to improve factory automation and communication, or you just need a dependable, easy to install plug-and-play safety network, our safety system can answer your needs. Thank you for joining us today.